Our planet is a world of grand spectacles.
The thundering herds of the Serengeti, the sprawling tapestry of the Amazon, the colossal march of glaciers. These are the engines of life we can see, the forces of nature that have captured our imaginations for millennia. But what if I told you that the largest synchronized movement of life on Earth is one we've almost entirely overlooked? That it happens not on land, but in the vast, dark expanse of our oceans? Every single night, in every ocean across the globe, an event on a scale that's hard to wrap your head around unfolds.
It is a procession of trillions upon trillions of animals.
A combined biomass so immense, it dwarfs the weight of every human on the planet.
Yet, you'll never see it from a shoreline.
You'll never spot it from a boat gazing into the blue. Because it all happens in the profound darkness of the deep.
A silent, vertical stampede that rises and falls with the sun.
This isn't just the greatest show you've never seen.
This nightly journey is something far more important.
It's a secret engine, a biological machine of planetary significance, humming away in the quiet depths. This massive migration is a key driver of a system that helps regulate our climate and fuel the entire marine food web, and tirelessly works to keep our world in balance.
Without it, the Earth we know wouldn't exist.
The very air we breathe would be different. So how? How do these legions of tiny, often microscopic, travelers hold such immense power? How does this hidden, nightly ritual connect the sunlit surface to the crushing darkness of the abyss? And, in doing so, help power our world? To understand, we have to leave the familiar world behind and descend into the heart of the ocean, into a realm of perpetual twilight, where one of the greatest stories on Earth is written every single day. Our journey begins where the sun's reach gets weaker. We descend past the vibrant, sun-drenched surface waters, the epipelagic zone, teeming with life.
Down, further down, into a world of deepening blue. We are entering the mesopelagic zone, better known as the Twilight Zone.
Stretching from roughly 200 meters down to a kilometer, this is a realm of immense pressure and chilling cold, and ever-fading light. Down here, sunlight is a ghost. This space is so vast it makes up about 20% of the entire ocean's volume,
and covers 60% of our planet's surface.
It is, by a huge margin, one of the largest and least explored habitats on Earth. For most of the day, this world is relatively quiet. But as the sun dips below the horizon far above, a signal penetrates the gloom.
The slow dimming of the already faint light is a trigger. a starting gun for the greatest commute on Earth. And then it begins. From the depths, a stirring. Trillions of organisms begin to move as one, answering an ancient, primal call etched into their biology. They are rising.
This is Diel Vertical Migration, or DVM. The largest, most synchronized migration of animals on the planet in terms of sheer biomass. The scale is difficult to comprehend.
Scientists are still working to pin down the exact numbers.
But the total mass of these migrating creatures is staggering.
But who are these tiny travelers?
They aren't the whales or the sharks.
The stars of this nightly show are the small and the overlooked.
The cast is led by legions of zooplankton, tiny, drifting animals. Among them are copepods, tiny crustaceans often no bigger than a grain of rice.
But so numerous their total biomass is thought to exceed that of any other group of multicellular animals on Earth.
They're joined by krill, pteropods, delicate sea snails nicknamed sea butterflies, and ethereal, gelatinous creatures like salps and jellyfish, all pulsing their way upwards.
Following this vanguard is an army of small fish.
These are the micronecton.
Lanternfish, their bodies studded with glowing photophores.
Light up the darkness, like a submerged constellation.
And bristlemouths, believed to be the most abundant vertebrate on the entire planet.
Move in untold numbers.
These are creatures built for a life of high pressure and low light. Many with upward-facing mouths to catch the marine snow that rains down from above. The question, of course, is why? Why spend so much energy on this colossal daily commute?
The answer lies in the ultimate evolutionary trade-off: eating versus avoiding being eaten.
The ocean's surface is a garden where microscopic plant-like phytoplankton create a rich buffet. For the zooplankton and small fish of the DVM, this is the promised land.
But this garden is also a killing field.
During the day, sunlight makes every creature visible to predators.
To be at the surface during the day is to be seen.
And to be seen is to be hunted.
The deep, dark Twilight Zone, by contrast, offers a refuge, a cloak of invisibility. But it's also a food desert. So, these creatures face a daily dilemma: starve in safety or feast in peril. Diel vertical migration is their revolutionary solution. It's a massive, planet-wide game of hide and seek.
Hide in the deep during the day.
Then, as the sun sets, rise to the surface.
To feast under the cover of night. And as the first hints of dawn threaten to expose them, they descend once more. This simple up and down movement, repeated by trillions of individuals,
is the rhythmic heartbeat of the ocean. It's the first critical turn of a biological engine that has a profound impact on the entire planet.
As darkness falls, the greatest feast on Earth begins.
The trillions of travelers arrive in the phytoplankton-rich surface waters and start to gorge themselves. This frantic feeding isn't just about survival. It's the first critical stage of capturing carbon. The phytoplankton at the base of this food chain are the unsung heroes of our atmosphere. Like plants on land, they breathe in carbon dioxide and use sunlight to convert that CO2 into their own tissues. When the vertical migrants feast on them, they are ingesting massive quantities of this captured carbon.
They're loading up on fuel for the engine. As the night ends, the migration reverses.
With bellies full of carbon-rich food, the great animal masses journey back down, actively transporting the carbon they consumed, hundreds, even thousands of meters into the ocean's interior.
This is where the secret engine truly kicks into high gear.
This process, the biologically driven sequestration of carbon from the atmosphere to the deep ocean, is known as the biological carbon pump. It's one of the most important climate regulation services on the planet. Think of it as a massive, living carbon elevator.
Every night, the elevators, the migrating animals, ascend to load up on cargo. Carbon. Then, every day, they descend.
Preventing that cargo from easily returning to the atmosphere. This unloading of carbon happens in three primary ways. First, through respiration. Just like us, these animals breathe out carbon dioxide. But instead of being released at the surface, this CO2 is released into the cold, high-pressure, deep water, where it dissolves. Multiply that by untold trillions of organisms doing the same thing every day. And it represents a colossal injection of carbon into the deep sea. This is what scientists call active transport. The carbon didn't just sink, it was actively carried down. The second mechanism is, to put it plainly, poop. These animals produce dense, carbon-packed fecal pellets that sink much faster than individual bits of organic matter. This constant downward shower of pellets is a key part of marine snow. A biological blizzard efficiently moving carbon into the deep. The third mechanism is the ultimate sacrifice: death. When a migrating animal dies in the deep, its body, a vessel of stored carbon, sinks, locking that carbon away for a very long time. So how much carbon are we talking about? The numbers are staggering, and a huge area of active scientific research. The biological pump as a whole is estimated to transport around 10 gigatons of carbon into the ocean's interior every year. Without this constant, active pumping, some models suggest that atmospheric CO2 levels could be about 200 ppm higher than they are today, a level that would catapult our planet into a much hotter state. Recent research is revealing that fish play a much larger role than previously thought. Mesopelagic fish, like lanternfish and bristlemouths, could make up as much as 90% of the world's total fish biomass, though estimates vary widely. When they migrate, they actively transport huge amounts of carbon.
Some studies suggest that in certain regions, the active transport by migrating fish and zooplankton can be responsible,
And in some cases, even more. This nightly ritual is the planet's single largest biological process for drawing down atmospheric carbon
and storing it in the only place big enough to hold it: the deep ocean. But this engine's impact isn't just about carbon.
The daily vertical migration is the fundamental circulatory system for the entire ocean ecosystem, distributing the sun's energy from the surface to the vast, dark majority of the planet that lives without light. Life in the deep sea is defined by scarcity. The Diel Vertical Migration provides a direct and reliable food delivery service. The creatures of the Twilight Zone that don't migrate, the sit-and-wait predators like the fangtooth or viperfish, depend on the daily return of the migrants. For them, the migration is a predictable meal train. Carcasses that sink into the abyss become a windfall for goblin sharks, deep-sea cucumbers, and bone-eating worms. Without this active transport of energy, the deep ocean would be a far more desolate place.
And the impact is even more subtle.
The physical movement of trillions of animals literally stirs the ocean. This biomixing creates turbulence that can influence the movement of heat and nutrients, like a constant biological stirring of the oceanic pot. This daily pulse of life also reshapes the ocean's sensory landscape.
The density of so many bodies creates what's known as the deep scattering layer. For decades, naval sonar operators were baffled by a false bottom that would appear on their screens several hundred meters down during the day,
only to rise toward the surface at night.
They were, in fact, detecting the dense layer of migrating organisms.
When we zoom back out, it's clear this process is a climate hero. For millions of years, this silent, hidden engine has been working in the background. A natural and powerful ally in maintaining a stable climate.
It's a testament to the power of biology to shape planetary geochemistry.
The daily imperative to eat and not be eaten, scaled up by trillions, has created a mechanism that helps regulate the breathing of the entire planet. For eons, this planetary engine has run with a steady rhythm. But today, this vital process is facing a barrage of unprecedented threats, all stemming from human activity.
The very system that helps buffer our planet is now being threatened by the consequences of our carbon emissions. The most direct threat is climate change itself, which may be creating a dangerous feedback loop. As the ocean warms, the surface water gets lighter, creating a stronger barrier between the layers. For a tiny creature, swimming through this sharpened temperature gradient is like swimming through molasses, and could make the daily commute too costly. At the same time, the ocean is absorbing about a quarter of the CO2 we emit,
leading to ocean acidification.
This is corrosive to creatures with calcium carbonate shells, like the delicate pteropods.
The decline of these crucial migrants could weaken a key link in the pump's machinery.
On top of that, warming waters hold less oxygen. And expanding oxygen minimum zones can act as walls, blocking migratory paths and shrinking their usable habitat.
Beyond these global changes, we're also inflicting more direct assaults.
Artificial light from coastal cities, shipping lanes, and offshore rigs can confuse the migrants,
disrupting the natural light cues that time their journey. We are, in effect, tampering with the engine's master clock. Perhaps the most alarming threat is the prospect of commercial fishing in the Twilight Zone.
As traditional fish stocks dwindle, there's growing interest in harvesting the mesopelagic fish. But these fish aren't just a potential food source.
They are a critical component of the carbon pump.
Removing them on an industrial scale could be like ripping the pistons out of the engine. One study showed that this type of harvesting could drastically alter the food web
and significantly reduce carbon export to the deep.
We risk damaging the entire structure before we even fully understand it.
The consequence of a weakening engine is dire.
If the biological carbon pump slows, more CO2 will remain in the atmosphere, which could accelerate the very climate change that is causing the problem. The deep-sea food webs that depend on the migration could face collapse. The engine's silent service, which we have taken for granted, could falter. For centuries, the ocean's depths were a realm of myth and mystery. But today, we're finally pulling back the curtain. We're beginning to comprehend the true nature of this hidden world and the staggering importance of the processes that govern it. We now know that every night, a biological force of incredible scale rises from the deep, working silently to keep our planet in balance. We've discovered a secret engine that has been powering our world all along. The great irony is that at the very moment we are discovering this engine, we're also on the verge of breaking it. The threats of a warming climate, acidifying waters, and our own industrial reach are putting this ancient rhythm at risk. But the first, most crucial step to protecting this engine
is simply to know that it exists.
It's understanding that the health of our atmosphere is inextricably linked to the health of the trillions of tiny travelers,
making their nightly journey in the dark.
It's recognizing that our actions on the surface have profound consequences in the deep. This story is a powerful reminder that our planet is a single, interconnected system,
filled with wonders we are only just beginning to appreciate. Far below the waves, in the cold and the dark. A heart of immense power is beating.
It's a heart composed of trillions of tiny lives,
each playing its part in a nightly spectacle that sustains us all.
And it's a reminder that sometimes the most powerful forces are the ones we cannot see.
The future of this planet may depend on us finally giving this hidden world the respect and protection it deserves.